everyone. Sorry that I can't be in person currently. We do it remotely, but I'm really happy to take the chance to virtual visit Latam. And now I know that usually nerds are not taking their feeling out, but I know that South America known for the hot temperament, and I guess that if people sit in that room and code in Python, they love Python. And that's the thing with Python, that people who write Python don't write it because that's the best language or the language with the most sufficient performance, etc. They write it because they love the syntax, they love the fast way that you're getting things done, they love the libraries that they can have. But that thing with loving programming languages has also a downside. And today I'm going to talk about this downside. My name is Gabriel. I'm like 10 years in full stack development. My main language is JavaScript, but I don't know how to write Python. And because people love Python, I get a chance many times to write Python. Either I don't know how to write them. And that's the thing with programming languages that people love. Many people who don't know how to write that language, writing it. And because this language are so strong, we get in many cases where we need to control those people who write the language that they don't love. So I want to tell you a story about 2018, a short story. I work at Cisco these days. And one morning we woke up to a call with the headquarters, and they told us that our products are rated as one of the worst 3 products in Cisco. That means people always complaining about our product, about that quality. And the meaning for that thing is that we don't get any budget anymore or stuff like that. The only thing we can do from that point is trying to improve our product and make it better. So you all know this diagram, you start to learn, you test stuff, you're failing, you learn, you improve. There are many diagrams of this time. This is the one we took. And then we started a period of like 3.5 months that 100 people. And now when I say people, we had a large engineering organization. Okay, I was part of that organization. It was more than 100 people from all the engineering profession. There was a Python developers, there was a tester, manual tester, there was full stack developers like me, there was system engineers, sales engineers. All those people gather in one room for 3 months and write 4,000 automated test cases in Python that supposed to help us to measure the quality of our product. Now, that was fine because our product getting better, because if you write 4,000 quality automation test cases, you test your product, you fix stuff. But then we start to run these tests nightly, and we discovered that the code that we write for these automation test cases wasn't that good. And if you look here, you can see that average of 50% of our test cases was failed in the nightly run. I was a tech lead in the organization, and I got the mission to try to fix the stuff. And then I tried to do some improvement. I've got into 70%, but everyone understands in the room that this one is not the best way to go. So I took the step forward and start to look at the code. Now, I want to remind you, that was a Python code, a tons of code that written by many, many people. Okay, and those people, most of them didn't know Python. And when I look at the code, and even I, that I'm not a good Python developer, saw something really bad there. I start to look at the code and try to understand how to make this code, okay, the automation test code, in a better quality. And to make it systematic, I found that there are four kinds of people who write Python. The first kind of people who write Python is, we can call it the Pythonista. Now, that point, that separation to types is actually valid for every modern dynamic coding language. Okay, but we are going with Python, but if your language is something else, you can stay here because the rules that we learn, the system is valid for every language. So the first one is the Pythonista, which is the good one. Okay, this is the code that we want our code to look like the Pythonista code. This code is valid. This code is working well. This code is something that we want all our code looks this way. The second type of code is the aliens. So we have many very good software developers in our organization, but many of them came from Java, came from JavaScript, came from Golang. But they are good developers. But they don't know how to write Python. And again, in any dynamic programming language, you find those people who write a good code, but in other language. I am, for example, writing Python in JavaScript. The code is Python, but the flavor is JavaScript. And that's bad when the code being complex and you need to add modules and stuff like that. The third is the descriptor. This guy, and that's more specific to Python because Python is also a scripting language. Many system people, IT people are writing scripts in Python. And they write code which can work, but it's written like a script. It's written like they are tell story. There are journalism. And for these people who are the descriptor, we are trying to make them code more clean. We are trying to make them keep solid. We are trying to make them do not repeat twice on stuff and stuff like that. And that's another kind of bad code. And the fourth is the journalist. Those people are people who never code in their life, but the easiest and cheapest programming languages courses are Python courses. So they're going to a 3 months, 1 hour in the evening Python course, and then they are coming to the project and start to write their code. Now they don't write code, they write text, which can be considered as code because in the time when they deliver it, it used to work, but for a long time, it just made your code looks like a blog about something. Now, the interesting thing about our code is that when they delivered, everything works. So what we need to do is trying to look at the code and find the patterns that made the code do not work after some time they deliver it. So what we've done, we have started to use linting and static analysis. What is linting? What is static analysis? In a couple of words. So everyone work in Python in the last years knows some libraries like Pylint, Pep8, Flake8, whatever it is. Every dynamic language has those today. Golang even came out of box with GoLint, which linting the code. Linting is the way you look at the code and trying to make this style better, like, taking all the small stuff which are anti-pattern in the code and take it out. Static analysis can be used for more things at your code. For example, if you want to run security tests on your code, you can analyze the code in a static manner and then trying to see if there are any security flaws. This one happened. We will talk a lot today about how to static analyze code. Let's look at it later. But what we've done is understand that we needed to write custom rules. We need to look at the code. Remember the 4 types of people. We need to look at their code, find the anti-patterns, the way where they wrote bad code, move it into a pattern, and then write rule that will enforce them to write better code. Remember, we want all the people to be the Pythonistas. So we can use static analysis on the code that they write, find their bad patterns, and trying to make their code better. So there are 3 methods to use static analysis of code. The first one that came to mind is, of course, do it raw. So we have here, for example, a piece of code, class test with there is one test is called unit test. and a function called test hello. Okay, this one is actually a text. The same as we are using string utilities and text function on text file, we can use on our code. So when someone delivers the code, we can just go over the code and, for example, check for spelling in the word unit test. As you may think, the row is the non-efficient way to move our code because code can be a lot of strings which are not always that structured from the string perspective. So we can use row method for static analysis, but we want something better. We want something that will help us to make the text more structured. And that's the next method to do static analysis on your code, which are tokens. If we look at a code file or every text file, we can look on every piece of that file and think, what is it? And then we can make from it an array or some structure of every token that we have in our text. Okay, so remember the code from the previous slide, the class test. Here it has two tokens, class and test, both of type name. But then we got the comment, so we called it operator, and then a new line. And then one indentation. In Python, this indentation is something important. We can run all over the indentation in a file and find if there is something that misusing of indentation. If, for example, we have indentation in number which is not modulo of 4, we can tell the user, you have error, because we know that Python have to be multiplied by 4. If we, for example, decided that our code is supposed to be with 2 spaces indentation, we can modulate with 2, like you see here. Okay, so my code is 2. And this way, tokenize is the next way to do static analysis on our code. But what if we are trying to look at our code in modules, right? Code is not just text. It's something that have relative between. It's something that relate each other. If we have a function, in this function we have argument, we have return. If we need to write all that stuff and try to guess the token, that could take a lot of time. So what we can do, and that's the best and the next method of static analysis, is of course use the AST. What is AST? So I guess everyone who attend computer science class here know the basic rules. So just a reminder, each part of our code is a node in a tree. Okay, when the compilers, when the interpreters running on our code, they don't do it in an array or something, they do it in a tree structure. And that tree structure is something that we can easily search of, is something that we can easily filter. Okay, because tree is something that we have many algorithms which are very efficient in searching stuff, ordering stuff, sorting stuff. So for this example, we have the same class, which is a module, which is our file. And in that module, we have one class definition. So here we have a node of class definition. We can get all the class definition in one file. We can easily know what is the name for each class definition. This class definition has 2 nodes. The first one is the body itself, is the function. The second is the basis. What is combining this class definition? We have one attribute called test case, and for each one, etc., we have the tree. And that's the most powerful way to do static analysis on the code. If we want to do something sophisticated in static analysis, we'll go with AST. So now let's try to look at the real world. How do we implement those static analysis custom rules on our product? So we have Pylint. Pylint is a library that came out of box with many static analysis code, with many static analysis rules. Okay, so if you know Pylint, and I guess if you wrote in Python last year, you know Pylint. Pylint is a library that giving you the option to write, they call it checker. Each checker is something that checks something in the code. So if we look at the out-of-box Pylint rules, we can find, for example, indentation checking. We want to check that each row, each class has 2 lines in the front. each file has one line in the bottom. Okay, and this thing you can understand easily. We can use tokenize to do that. Another check that we have in Pylint is that every return is reachable. Okay, we can write a function, but then there is a return that will never reachable. Pylint will know about it. They will look at the AST and they will find if there is a return with no nodes that can lead to it. Okay, so this is the out-of-box Pylint checkers. We now want to look at our code base, which has many patterns of bad code, and implement our custom rules on that code. Let's start to see. So we have the Pythonista. The Pythonista, as we said, has the out-of-box, the PEP8 style guide that implemented already as a checkers into the Pylint, and we can trust that the basic version of Pylint will keep her safe. Let's go to our Lion. Our Lion was the best Java developer before we started to write Python. He's a guy with thousands of years experience in Java. And because you're writing Java, you know that joke. To build a horse in Java, you need to build a horse factory. And factories need cities and need electricity and need so on and so forth. In Python, you just build a horse. In Java, you build a module. And we want to avoid this alien from building class where we don't need it. Let's see how we do that. So I prepare in advance a code that do custom checkers. I'll not go on the code itself line by line, but I prepare in advance also a debugger that will help us to see how to write those. So we have here a redundant class checker. Every Pylint checker is a class. Okay, now we need those class. And why we need those class? Because this class is inherit from base checker. And if we look at the base checker, we see that it has init function. We can understand pattern. We can understand that Python class is only needed if it had a constructor. If it don't have a constructor, we don't need a class. It's not a Java. So we want to notify the user that if you're writing a class without init function, we want to give them error. Okay, so let's see how it's look like in the real world. So I already prepare a redundant class in advance. We have here the handler of a lion. This lion wants to do some handler to get GitHub repositories. Okay, and here you can see that we already, I'll explain how it works, but here you can see that we already notify this user. Okay, man, this missing init function class should not be used. This guy can try to fake us, so he will write init function. Okay, let's look here. If we will implement init function, we can see this was ghost. But now let's look at the init. Hey, if you have a constructor without self assignment, that means you don't need that constructor. You just try to cheat us and write an empty init function. So this guy will now think again. Do I need a class here? Do I want to go to the internet to check if I need a class here? So if he decides that he needs a class here, for example, for the token, he can write self-token. And as you can see, this error is gone. Now the class is valid. Let's see how we implement this rule. So we have the checker, and as I said, the basic checker in Pylint are using AST. Here we will use AST. And Pylint is using a library that called Asteroid that give us a lot of utilities functions to use AST. We will use here one utility function. This function called leave class def. So you remember the AST has many types of nodes. It can be class, can be function, can be string, can be a lot of those stuff. So here, for example, we use the class def, and every time we leave the node of the class def, we will want to call this function. And here we will want to travel. So if this class has bases, we are fine, right? They need this class because they want to inherit something. Now let's check if this class has a constructor. So here we have an iteration on the method of the class, and we want to check if the init, the Python constructor function, is implemented. If this class has no constructor, we want to notify the user. So we will add a message. The messages are defined here. Every Pylint checker class should have messages, a checker with messages. So here is the first message. So we config one check. What about the next check? Okay, so it has constructor function, right? We find it. Now we want to check that this one, and here we can go into the node. We look at the node of this function and check if this has assigned attribute. Again, we traverse the tree. This is why trees are efficient. We can traverse of it and visit nodes without many loops on those arrays and tokens. So here we can see that if it has self-assignment, we are, if it's not have self-assignment, we are giving another message. So this is an example for an AST that now will prevent our alliance from writing a redundant classes. Now let's go to our next one, to the descriptor. You remember the descriptor? You know to write script, and you know what people do when they write script? They wrote every piece of code as many scripts that need that, but a code project is not the same. Code project should have only one place, right? This is the one, the D in solid, don't repeat yourself. We want to teach her to do not repeat herself. So we saw a pattern. We saw a pattern that every time the descriptor want to do HTTP call, they use the same code again. And we want to prevent her from doing that. We have one implementation from the HTTP client. If we have something in that HTTP client, we want to fix it in one place, not in many places. So I use the raw one to write here. Okay, so here we have the description, which she is writing request get, GitHub client get. We want her always use the HTTP client. Okay, the GitHub client, as you can see here, is using the HTTP client. We don't want her to use the request JSON. So what we can do is limit the import. We can here tell our user that request library should not be used. Use HTTP client instead. I use the row to write this rule, which are not the most efficient way to do that, but I want to see how it works. Okay, so every Python row file checker can inherit from this Pylint class. Okay, which means we will have one function that we need to implement here, process module. The module will be the class, of course. So we want first to check if this HTTP client. Remember, this is the only place where we allow to do HTTP calls in our code. We don't want everyone to do HTTP calls everywhere. We want everyone to use the client. So we check which file is that. If it's HTTP client, we don't want to limit that, right? This is the place where we want. But if not, let's move on the lines. Now, as you can see, it's not the most efficient way to do, but we can see if this line is request library. If it's import one of these library, request or URL lib, we want to limit it. Okay, and then we'll add a message, right? Now, if we go to the descriptor and we see that the message here that request library should not be used, we can just remove this one and see, oops, disappear. Okay, we don't know where the request, but we need to import the HTTP client. But at least now the descriptor will go to the internet and check why it's important to do not repeat yourself. Remember, your messages should be descriptive. I don't want the best here. Okay, I just assume she will understand, but be descriptive in your Pylint. The last one that we have is the journalist. And I know many junior people. I like to mentor junior people. And one of the things I like them to do is use a very good anti-pattern called the Golden Hammer. They go to a programming course and they learn one thing. They learn, for example, to use if. They learn to use for loop. They learn to use while loop. And then everything in the code is using this way. So we want to avoid them to use this golden hammer pattern. So in our case, we have the journalist that just learned how to use if statements and she just used if statements everywhere. So we want to ask her, please use match case, which is like switch case in human languages, instead of using if. And for this one, I use the tokenization. Let's look how it looks like. So we have, again, the same as you say, I just inherit from the relevant Pylint checker. So here from the base token checker. And the base token checker need to implement the process tokens, of course. What we will get here, we will get the list of the tokens. Okay, right. So you remember the one that I show you in the slide. So if we remember this one, I'll not go to the debug now, we will get something like this, an array of our tokens. The same one will get to our code, right? So if we look here, we see that every token is an element in the array of the tokens. So we are looking at the tokens, check, do we have if here? Okay, if we have if here, we are trying to get the condition from that. If this is just a simple function I wrote to get the condition as a better structure, and then we can check all the condition in the same block of those if, and then where we have the condition, we can check if those conditions are the same. If she is always trying to compare, to do statement on the same condition, we want to tell her, hey, please use match case and not if. Let's look how it looks like in the code. So you can see here, she checked again and again if the action is get repositories, and we try to tell her, hey, this is anti-pattern. Multiple if statement with the same action, condition found. How do we know this is action? So nice thing we can do with Pylint messages is, of course, format them. Yes, I save you what was the left-hand side, what was the condition that keeps the same, and then I pass the argument, the condition, into the message. And as you can see here, I format the condition into the match case statement that we want to prevent. So here we just had a brief, including the code for 3 Pylint checkers that we can customize. Now look at your code. I'm pretty sure that you will find something that needs to be customized. It can be a framework that you write yourself. It can be the same case like ours, that 100 people are forced to write in language that they don't know how to write. And after you have this custom checker, it's a time for hierarchical code base, which is a very nice model. So let's think about it. We can take those rules and put it in our CI/CD. If we are put it on a CI/CD, we can just find a better way to allow only the code owners to deliver, the Pythonista to deliver without this custom checker, the code that maybe need to be in this way, but all the other write the code in the exact way we want to write it. Let's make a code more beautifier and works better with the custom lint rules that need to be done for our code base. Thanks for listening. I was Gabriel. I'll be happy to be in touch. Any question, if you have. I'm available on Twitter, on GitHub, and LinkedIn, mostly active on Twitter, so I'll happy to connect there, or LinkedIn. Thanks.
Bienvenidos de vuelta al track de seguridad, y acá estoy con Gabriel Manor, que recién escuchábamos su charla. Voy a switchar al inglés, así que... Hi Gabriel, how are you?
Good, how are you doing?
Okay, cool. Is it your first Nardearla?
Yeah.
Okay, welcome then. Okay, so I have a few questions from the audience after them hearing your talk. The first one will be, how easy is to incorporate static analysis custom rules in CI/CD?
Well, actually, if you already run static analysis library as your CI/CD, what we recommend to do is creating like a dedicated repository for the custom rules. And then in the action, no matter if it's a GitHub action or a Circle CI job, you can just simply clone this repository and run the rules together with those rules. You can also put it in the specific repositories. So, I mean, if you have for some library that you want to customize the rules for that, you can just put it in some library and then point it in the CI/CD runs. But if you already run a linter or static analysis library, that's not a big problem to get together the custom rules or queries and run it together.
Okay, cool. And what are the areas that you find most useful?
Well, so my best one and the biggest project that we used to do custom static analysis rule was a framework that we wrote, and then users abuse that framework. And then we actually write custom rules and get our developer use the framework as we plan to be. Actually, you can find it also, I know JavaScript libraries like Angular and React, that there is many custom sets of rules that make people write React and Angular in the good way.
Right.
So this is the most useful. We also use it in some security, particular security rule to keep code owners and keep some dangerous code from security Manor to be delivered to the code base.
All right, cool. And another one from the audience here, are there any specific tools for particular domains? What about other languages?
So we talk about Python and Pylint. JavaScript has a great tool called ESLint, Go as GoLint, which are the first one to choose. If you're going to the security domain, there are a couple of SAST libraries for each one of the languages, but there is also semgrep, which is a cross-language static analysis library used particularly for security. I actually don't really like semgrep because it's quite slow, and that custom rule feature I think that their writing for the particular language is better, but many people found semgrep as a good choice to start.
All right, cool. And for people at home listening to you now that may want to start learning about these things, do you have any authors, books, blogs, or things to recommend for them to go find more information?
So actually, I like, learn from scratch, learn from the bare metal, as the mean. So the bad thing, in my opinion, is think about custom rule and start to try to implement that. It's a bit different between the languages, but each one of the libraries has a very, very good documentation. So just go to the official website and find something.
Okay, go back to the basics and read documentation, right?
That's
about it. All right, cool. And you were telling me before we went live that this is your first Nerdearla. What were your expectations for this event? Did you know it from before?
Well, so I actually heard about it because, all the cool materials around, etc. I really like, the vibes and those stuff. I actually planned to be in person, but I had many conferences this week and the week other, and just get all the way to Latam now will consume too much time. But I really hope to make there in person next year. Oh,
yeah, that will be awesome, and we'll be waiting for you, Gabriel. Anything else that you would like to add to our audience today?
Not really.
All right,
just
cool. Thanks.
Happy that you listened to me, and thank you.
Thank you for joining us. Y para los que están en casa, los saludo. Vamos a una tanda súper corta y ya volvemos. ¡Vamos a nerdear!